like I said, we've got to get this one out of the way so we can actually get to 5 and start some stuff for A and P. Now, this is a list of those important minerals in the body. Calcium, chlorine, chromium, I know you'd kind of be like, what? Cobalt, copper, fluorine, iodine, iron, magnesium, manganese. All of these are going to be important in some way. But when you begin to look at their numbers that are needed, calcium, of course, is the one that has the most amount, okay? And that's actually in milligrams. Now, for the chlorine, okay, this one is thinking about how you're going to take it in as table salt. And, you know, table salt's heavy, all right, if you've ever weighed it. But look here, a lot of these are in actual micrograms. All right, so these are very trace amounts. However, very important when we begin to look at how they function in the body. How many of y'all look at this label on your foodstuffs? I do. And these percent daily values, think back to the amount that they say we should have. The 60, 30, 10, okay? And then, you know, somebody, I guess you would be counting, they might count the percentages or they might count the calories, whatever the case might be. Now, these percent daily values, they're actually related to someone who might be on 2,000 calorie a day diet. Wow. Anybody in here eat that much per day?
2,000 calories a day. Probably more 1,000.
What's, yeah, see,
Small amount.
2,000 calories?
Depending on what you eat.
Actually, depending on what you eat, but 2,000 calories can actually be a lot for food, depending on what you choose. Like, say, for example, veggies, all right? I mean, that's why you could have, you know, a plate this high of veggies and still be under 2,000, okay? But go to McDonald's and get the Big Mac, and that's all you probably get to have. You know, just saying. So it's really relative to what you eat. But it is a high amount. Do you happen to know about how many calories your body needs per day just to function? Like 1,200. Okay? To do nothing but, I mean, now granted, this means nothing all day but just this. Now, granted, if you begin this, you probably need about 100 more. All right? So, you're not looking at needing a whole lot in your daily diet, okay? Now, the goal is whether you want to gain weight, lose weight, however it might work, all right? And you do have to kind of pay attention to that calorie usage and intake. Now, this is a good example of reading the labels. Are these labels always correct? No. Why?
If they want to manipulate it so that it seems like you have less fat in the food or less salt in the food, or, you know, they're able to manipulate it to read when you don't really understand what you're actually getting.
Yes, because there's no regulation. Yeah, so it's a huge issue. Now, like I'm saying, you know, we've talked about this one quite a bit because metabolism, all those chemical, all of those chemical reactions that take place in the body, all of that makes up the metabolism. When we look in the body and some process occurs to break down a molecule, this means that we are going to take the bonds that are found holding the component parts of that molecule, and we're going to break it down. And when we break bonds, energy gets released. So, for example, leave that up there because I'm going to need that. What is that? That's my glucose molecule. My body is going to take all of the energy that is stored told y'all I'm not an artist. Is that it? 1, 2, 3, 4, 5, 6. Yes. In that 6-carbon ring, that'll have, you know, the O's and everything around it. And those bonds are going to get broken. And when those bonds get broken, it releases a huge amount of energy. When this happens, it's called catabolism. When the body has to take component parts, molecules, put them together and build a bond. That means we have stored energy, and that is anabolism. Those two terms you're going to see quite a bit in your textbook. Now, when we talk about producing energy for the body, like I've said, we want to use sugars first, lipids second, proteins last. For the most part, other materials the body is going to be using to make or use or create or get in some way in another form. Now, what tends to happen when the materials come into the body, and we'll take a material and we break it down, there's usually the reaction occurring to build something up. So what we say is that a lot of these reactions in the body are coupled. So when you think about coupling, I think about plumbing and how you like maybe hold two things together with the coupling, okay? So if, for example, we're thinking about ATP, this energy molecule. ATP, the structure is going to be that huge adenosine phosphate and then my 3 phosphates. Now, in the form where it has 1, 2, 3 phosphates, is this a high energy molecule or low? It is high. Why? Because I have all bonds. I've got all 3 of them between those phosphates. Okay? Now, let's say that I need to use this ATP and send it off to a particular enzyme, and it powers that enzyme. What does it do to power that enzyme?
Drops off the phosphate.
One of the phosphates breaks off, and it powers the enzyme. I have now formed ADP. But as soon as the power is used, what's released? My phosphate, and I now get to go back to being ATP. So utilizing ADP, it's coupled with ATP. Does that make sense? I started with high energy, went to low energy, came back to high energy. Sort of recyclable, so to speak. Okay? So now, ATP synthesis. the making of ATP. Okay, like I said, the one molecule that can be used to make ATP in either the cytoplasm or the mitochondria is my glucose. Now, glucose is the material that we'll use to talk about total cellular respiration. Anybody remember this term? All right. Cellular respiration. Let's kind of look at this again. I'm not going to spend a whole lot of time, okay, because hopefully you've talked about this like 500 times, okay? Now, what I've got for you over the next few slides, what I've got is every single step. I'm not asking you to know every single step, but I want you to see what happens, because those electrons are going to become important. Okay? So let's just kind of follow what takes place. In ATP synthesis, making those 36 to 38 ATPs, all right? Well, when a glucose molecule enters into the cell, we're going to have to initially invest some energy. So we actually have to supply some ATP. That ATP allows for that glucose molecule to be rearranged. Now, in the case of the aerobic respiration, all right, that 6-carbon glucose molecule breaks down into 2 3-carbons, which are my pyruvic acids. The pyruvic acids can begin to enter into the mitochondria, go through the citric acid cycle. I learned Krebs, okay? Go through the citric acid cycle. Let's say that's 6 times quick, okay? And then hit my electron transport chain, and it's the electron transport chain where the majority of the ATPs get produced. That would be the glucose molecule going through the entire process. If this were a cell that needed energy quickly, i.e., a skeletal muscle cell, and you're going to be running a race, and when you begin to run a race, all right, you're out there and you're like, you know, you're doing all this stuff to be stretching, all right? You know, okay, getting all them stretches done. And then you kind of like, okay, all right, now you're going to start running that race, okay? You take off and you start running. Now, I don't run, all right? Like I have said, if I'm running, you need to run with me, okay? Now, people who like to run for the fun of it. Okay, so they start out running. And about the first minute, okay, doing all right. And after about 45 seconds or whatever, they're going, and about 2 minutes into the race, they're finally, they've hit their stride, so to speak, okay? In order for their body to do that, the first thing that it had to do was supply, well now first of all, we don't store ATP, all right? So ATP that was